Hello, I'm Patty Simpson with Simpson Math. Is 100 a big number? Well, it kind of depends on what we're comparing it to, doesn't it? I mean, if I make $10 a week or $10 a month, $100 is going to be a lot of money. So for me to have to pay $100 when I'm making $10 a month or $10 a week, $100 is a lot I'm having to save up for. So that $100 is a lot. But if I'm making $100,000 a month, $100 is nothing. That's nothing. It's just this little bitty bit of money. So 100, it's relative to what we're comparing it to on whether or not it's big. Maybe sometimes you hear talk about the United States budget, and you'll hear them talk about millions of dollars. And you ask yourself, is $1 million a lot? Well, again, if we're comparing it to my salary, $1 million is a whole lot. But if you're comparing it to the United States budget, where we're talking about billions of dollars, $1 million is not that much. So it's all relative to what we are comparing it to. And here we're going to talk about relative frequency displays. And that's exactly what we're talking about, is comparing a piece to the whole. Is this big or not? I don't know. If my data value is 2, is that a lot? Well, if I only talk to 2 people and it's all 2 of them, then yes, that's a lot. But if I talk to 10,000 people and only 2 of them said something, then 2 is not very big. So we looked at frequency, but how do I know if 2 is big or not? So here we're going to look at relative frequency. And that's all relative frequency is. It's the fraction or percentage of the data set that falls into a particular class given by, so it's just a fraction or a percent. This says the exact same thing. It's just a way to denote it or to write it. Here I have the frequency out of the size of my sample. Or if I have a whole population size, it's the frequency out of that population size. It's just the fraction in that category. So a relative frequency distribution display just displays those proportions of data set that belong in each class. The most famous of all of these displays, relative frequency displays, is our pie chart. The pie chart shows that percentage. So I can look and see that this category, this class, has more percentage-wise compared to the whole population. This has more than that part. So I don't know the numbers, the frequencies, but I do know the parts of it. What fraction does this make up? So my fraction of fuzz stripes is bigger than my fraction of Oreos. So that's what that tells me. So the pie chart is the most famous of those. And that pie chart just shows those percentages or those relative frequencies. Now, our pie chart should always add up to be 100%. So here the percent is missing on this piece of the pie. By the way, I can tell by looking at this pie chart that there were 1, 2, 3, 4 categories in my pie chart. Pie charts always show qualitative data. So pie charts show qualitative data. Those different categories is what we're showing with a pie chart. So here I have 4 categories, but that one's missing his percent. So let's see if we can figure out what that percent is. Since our pie chart should always add up to 100, the first thing I'm going to do to find out that percent is just add up those 3 categories. This one was 40%, this is 25%, and that one was 28%. I'm just going to add those up to see what percent I have. That's 13, carry 1, 6, 7, 8, 9. So I'm at 93%. I need it to get to 100, so that means if I added another 7, or if I subtract from 100, subtract that 93 from 100, I'm at 7%. So my pie chart should always add up to be the full thing, that whole data set, the whole thing, which is 100% of it, or one whole thing. And then each one of these is just a piece. Then I can figure out how many people answered if in each category, if I know the total number of people that were surveyed. So for instance, if my sample size is 100, if 100 people were surveyed, then I know that 40 people said fudge stripe, 25 people said Oreo, 28 people said Chips Ahoy, and 7 people said Keebler's Chips Deluxe. So notice this 7%, if 7 people said that, it's 7 out of the 100 is how I'm getting that 7%. So this is that 7 relative to my overall population. What if my population then is 200? How do I find out how many people said Keebler Chips Deluxe? Well, if it was 7 out of 100, then out of 200, well, I multiplied by 2 to get there. That's 14 out of the 200. I could also do this. I could take 7% of 200 to find out that amount. So another way to find out is if we know the total number of people that were surveyed, we can just take the percent of it. So let's say that I have, let's use not a pretty number, like 360 people that were surveyed. If I want to know how many people said fudge stripes, I would just do 40% of that 360 to find out how many people were surveyed, or how many people said fudge stripe. Or let's make this, instead of 360, let's make this 15,000. So then I would say 40% of that 15,000 is how many said fudge stripes. So 40% of that, well, we know that 10% of that, you just move the decimal over one spot. So if 10% is 1,500, then we just do 4 times 1,500. 2 of those is 3,000, so 4 of them would be 6,000. You can check my math there to make sure. So that's how we find out. If we know our total number of people, then we can find out how many are in each piece. So pie charts show qualitative data, and they always show relative frequency. And they're our most famous of those relative frequency displays. A few things about pie charts that we always need to remember to have if we're creating our own. There should always be a title to let our reader know exactly what data is being presented here. And then we should always have a key for our pie charts to let us know where to look, that the Oreo matches here because this symbol is right there. So you've always got to have a key along with your pie chart. Math Made Simple is Simpson Math. Thanks for watching.